Guys, welcome to today's session. My name is Ernest, like we all know, and I'll be taking us through the basics of Golang syntax. So let's just get into it. Let me share my screen real quick. Okay, cool. Please confirm if my screen is visible. If you can see, just let me know if it's. Okay, I think it is. Right. So, good evening, guys. Once again, let's not wait too much time over here. I'll be taking us through the basic syntax in Go, like I've already said. And so, this are objectives for today's session, right? So, at the end of my presentation, everybody here should have a fundamental overview of Go syntax, and we should also be able to write simple, correct, and efficient Golang programs. And at the very, very, very end, right, if you don't pick anything Krana, you should know what variables are, what functions are, what loops, conditionals, and defer statements also are in Go. So this will be a pretty short presentation, and hopefully we all get the grasp of what or of how Golang's syntax looks like on the fundamental level. So let's get into it. Like we saw last week, right? This is how a basic Golang program looks like. And so every Go program starts in the package main, and depending on what you're doing, right, you might want to import certain packages, maybe internally or externally, to use them in your program. But the long and short is that everything you are doing starts in the main function. So your main function over here is the entry point of execution. It doesn't matter what you are doing. At the end of the day, everything will start in your main function. And so if you look at this screenshot over here, this is like a simple hello world program. So that will all get a grasp of how a Go program is structured. So you have the package, you have some imports if necessary, you have your main function, and then it prints a hello world. So that's all for the basic structure in Go. Now let's talk about variables. I mean, you can't talk about writing code without variables. So if you're already a programmer, I'm sure you already know what variables are, but they are essentially ways for us to define containers to store values so that we can use them multiple times in our program. And in Go, we can declare variables in two ways. We have the explicit variable declarations with the var keyword. So whenever you see the var keyword, just know that it's an explicit variable declaration. And you can also let the compiler infer a type for your variable using the colon and equal to. So if you look at this screenshot over here, right, you can see we've used var keywords over here. So these are ways that we tell the compiler that, oh, we are declaring a variable, but then we are doing it explicitly. And then there's this group variable over here called Golangana, which uses the inferred declaration essentially, right? So if let's go to VS Code for a minute, and so that's how we declare like a basic variable in Go, right? So we can just do maybe var name string, and let's say my name is Ernest, right? So we'll do this. This is like explicit variable declaration. And if maybe my age is also a variable, and then I want to let the compiler infer the type, I can do age with a colon and equal to equals maybe 59 because I'm 59 years old, right? So yeah, this is like the two main ways of declaring variables in Go. But another thing you might also want to keep note of is that Go also provides us a way for us to declare variables without necessarily giving it a value as we declare it. So you see over here, we did var name string equals Ernest, and also did age equals 59, right? But the way that we can actually declare variables without giving it a value. So if we come back to our presentation, you can see that there's var name string, var age, and var height is a float. But we don't actually see the values that these variables are actually supposed to contain. And so whenever we do that, right, let's say we have this, and then we have um, var age, let's say age is an integer, right? What actually happens over here is that the compiler finds a default value based on the type that your variable is, and then it assigns that value to your variable. So that you won't, if maybe you try to use the variable without giving it a value, you don't tell you that, oh, maybe your variable was uninitialized or something. And so these values are called zero values. So zero values are essentially default values that the compiler assigns to your variables before you actually give them or before you actually override them with your own values. So if let's say we were to print maybe age, for instance, right? Let me comment out the name. Okay, we can also print the name as well, right? But depending on the type of the variable that it is, the zero value will change. And so for strings, it's just an empty string. So the compiler will give name here an empty string like this, and then each here would also be zero. So if we print this, we'll just see the zero, right? We won't see the empty string because it's empty. But the point is that these values are not just some now somewhere in your memory and whatever, right? The compiler will just find some value B and give it to it so that if you try to use it, they won't come and tell you that. I mean, if you're familiar with languages like Java, it happens a lot, right? They don't even allow you to do some of this. So this is like a pretty nifty thing that Go allows you to do. And also another type of variables that we might also want to keep note of are constants. And so constants are essentially variables that don't change. They are read-only variables. So if maybe you're writing your code somewhere that maybe you know the value beforehand, right? You know the value of a variable beforehand, and you know that that value also won't change. Let's say if I, for instance, right? Maybe const I equals, let's say 3.14, right? So if we do this, the compiler looks at the variable pi and says that, oh, it's a constant. It's not going to change at any point in our program. So we can use it anywhere, but then we can't necessarily override this value. We can't come down here and come and do pi equals 3.15. The compiler will tell you that, my friend, you can't assign to pi again because you've already said it's a constant. So let's not try to backtrack our words essentially, right? So this is also another thing that Go allows us to do. If you're familiar with JavaScript and other languages, they all have their ways of doing something like this. So it shouldn't be something new. So the next thing that we might also want to talk about are types, right? Go actually uses a static type system, which means that whatever variables or whatever values that you are using in your program should have types at compile time. And at compile time, I basically mean that when you are writing the code, if you look at var name like this, we are telling it's not only just the compiler safe. If somebody else is reading your code, right, they can look at the var name and know that, oh, maybe name is supposed to store a string, age is supposed to store an integer, and so on and so forth. But we have multiple types in Go, right? We have the basic types and the primitive types. So we have primitive types and composite types. Sorry. So let's talk a little bit about these types. So the common variable types include the integer, the float, strings, and booleans, and they are called primitive types, right? By primitive, another word is basic. You can call them what feels good for you. But primitive types are essentially the built-in simple data types that hold a single value. And so, like we said, we have the int, we have the float, we have the string, and the boolean. There are a lot of them, but I think these four, for basic purposes, will do. And we also have composite types. And for composite types, they are essentially like the basic types, but then it just uses it builds upon the basic types we have above, right? So they contain multiple values into a single structure. Examples would be arrays, slices, maps, and structs. So let's get into maybe how we can declare some basic and composite types in Go, right? So I'm not really going to waste that much time on basic types because I feel like we've already done it. So maybe if we have, let's say, we are building an API somewhere that we want to check if somebody is an adult, right? We can use a boolean. And boolean essentially means it holds true or false. So if wherever we see a bool, it holds true or false, like this. So we can do var is adult, maybe bool, and then maybe the person is an adult, so true, right? So adult here is a boolean. Maybe another thing would be floats, where we can do maybe var score, right? Float equals. So floats are like they are called floating points. Essentially, you have values after the decimal point. There are a lot of nuances around it, but let's just keep it at that. So let's store maybe 89.5, and then there are also strings. Var name string, like we saw previously, equals Ernest, like this. So these are like very simple examples of primitive types in Go. And there are also composite types. Like we said, we have slices, we have arrays, we have maps, etc. So let's get into some, right? So one way we can declare an array would be to use the square brackets and the type that your array is supposed to hold. So whenever you see square brackets in Go code, you know that it's an array. So you do like this, and you tell the compiler the type that your array is supposed to hold. So in this case, we are going to store some integers. So we'll just say int. Let me add one, maybe var age int equals maybe 5, right? So int like this, so that the compiler will know that, oh, maybe this array is storing integers. And then depending on how you want to do it, right, you can declare arrays and also give them values at the same time with curly braces. So I'm going to do maybe 1, 2, 3, and then after we can give our variable a name. So we can do var maybe nums equals. But here's the thing, right? Arrays, with the way arrays are, right, you have to tell the compiler the number of values that is storing as and when you declare the array, right? So in this case, since our array has 3 elements, I'm going to put 3 uh, square brackets like this. So the compiler will know that, oh, num is actually an array of integers and it only stores 3 integers like this. So this is an array declaration. And there's also another thing called a slice. So a slice is the same as an array like this. It looks just like an array, but the difference is that it's dynamic and it's resizable. The thing about arrays is that if we say that, oh, maybe this array contains 3 integers, we can't come and add a fourth integer to this array because we've already told the compiler or whoever is reading our code that, oh, this array is supposed to contain 3 integers. So we can't add a fourth. So that's the advantage that slices give us. If you want to add a fourth, maybe you don't need an array in the first place. You can use a slice. And so with slices, we just make whatever number is in the square bracket and then let's rename this to maybe SLC, and then let me give this a meaningful name, maybe num slice like this, and we'll store this. So you see, it looks just like an array, but it's resizable. We can add more. We can just keep on having fun with it. But in this case, maybe let's not store integers in our slice. Maybe let's store a string because strings are also basic types, so that we'll know how composite types actually build on basic types, right? So we can do maybe languages, right? Languages, which will be a slice of strings, and then we'll do maybe Go, Python, and then maybe Rust, like this. So this is how you initialize a slice in Go as well. Maybe we can choose to print so that we see how it looks like. Maybe languages. Yeah, let me comment this out because I don't want to print all this. Yeah, so you see how it is. So it just square bracket and then whatever strings we put in. So that's it. Another composite type we also have would be the map, right? And so maps are essentially also types that store key value pairs, right? If you have maybe like a collection of keys and values, I'm sure we are all familiar with like JSON data, where it's like, oh, you have this and maybe name and then Ernest, then the age. Sorry, somebody raising their hand. Oh, okay, cool, no problem. And then we have age and maybe 15, right? You might want to store this maybe when you're writing a Go program, and there's a type called a map that you can use to store this. And so if you want to declare a map, you just need the map keyword, right? So there's a keyword in Go called a map. Where you just tell it the values that you want to store and then you store them in there. So I'm going to type map like this. And what is the map going to store? So let's say our map is going to store strings and integers. Maybe let me do the score. Let's say maybe 5. So when we type the map keyword, we'll need square brackets and then the key. So what is the type of our key? So in maps, right, we know that they store keys and values. So keys are essentially the ones on the left and values are the ones on the right. So our key, the type of our key is going to be a string. So we'll just type string here and we'll come outside of the square brackets and we'll say that, oh, what value will this key hold? This value will hold an integer. So we'll type int like this. This is all you need for storing key value pairs in Go. And maybe you can add some values. You can do maybe um, let's say name, maybe name can't really store an integer, right? Maybe let me say Ernest, then maybe my age, 59, and then who else? Maybe Augustine is also here, so we'll do Augustine, and maybe Augustine is 85, right? So we'll do this, and then we would want to assign this to variable, right? So we can use the inferred variable declaration. So maybe names, and then we'll do this equals to this, right? So this is like how we would store a key value in Go. So maybe we can print this so that we'll know how that one also looks like. Let me comment this out. So when we print this out, right, you see it also gives us some square brackets over here, but then uh, it sits with a map so that when we see it, we'll know that, oh, there's actually a map of, people's names and their ages. So guessing is 85 and Ernest is 59. There are a lot of nuances around it, but I think for our presentation today, we should just know how to, initialize maps. Or perhaps if you have a question too, you can just write them down and ask. But that's what maps are. Another type I'd also maybe want to talk about are composites. The last composite type would be the struct, right? So you can look at structs like a custom data type. So you can choose to design your own data type as and when you want, if maybe you want to group something together. So assuming maybe we are storing something about a user, and then we know that, so maybe our user will have a name and an age, right? In other languages, you might store them in something like classes, but in Go, we can use structs so that we can essentially group all of those related data into a single structure, essentially. And so in declaring a struct, you need a keyword called type and what we are actually storing. So maybe the name of what we are storing is called user, and we'll say, oh, it's a struct. So this is all you need for a struct, and then you open it with curly braces. Maybe what are you storing? I'm storing the name, and you give it a type, because again, we are looking at a very strongly typed language over here, and we'll add age like this, which would be an int. So this is all we need to, design our own data type or design our own structure in Go. But now that we have our structure over here, we actually need to give it some values, right? So in our main function over here, we can now add some values to our struct that we've defined at the top. And so we can just type the name of our struct, which is user. So we can do user and we'll open it with curly braces. Now that we've opened it with curly braces, we need to store what actually we put in our struct. So we store the name and then our age, right? So we have to come and tell the compiler that, oh, now we need an instance of this user and we need a name property and the age property. So I'm going to do name equals, let's do Augustine, and then age. How old is Augustine again? 85, like this. And then we can assign it to a variable. So we can do, oh, maybe u equals this. Very simple, very, very simple. It's not complicated. So we can run this. So you see that it gives us Augustine and 85, which is their names and the ages respectively. And so these are some of the most common types that you see when you are writing Go programs or when you're even reading somebody else's code. So let's all keep note of this so that when we come across them, it wouldn't be news to us. And let's move on to functions. And so as and when we are writing programs, right, there are some logics or there are some stuff that we do in our code that maybe we might want to use them in multiple places. And in order not, or even sometimes in your main function like this, right, you see that even with the small presentation that we are doing, our main function has become very cluttered. And so there are instances where we might want to group our code in certain units so that we can call them and use them wherever we like. And so we use functions to do that. And in Go, like I said previously, everything starts in the main function. But you can see that this main, so main here is the name of our function. But then what actually tells us that it's a function is a keyword func. And so wherever you see a func keyword in a Go program, you know that, oh, we are dealing with functions over here. And functions take something called parameters, which are basically the things that you pass to a function when you call it. So you can look at this print line like this. Print line is also a function, and then we give it a parameter of u, which is our user struct. And so if we define a function, we also need func keyword, maybe func greet. So let's write a small function that's going to say good evening to everybody here. right? So we'll need func and then the name of our function, which is greet, and then we'll open some brackets like this, and then we'll use some curly braces like this. Now, the thing about functions are also that the parameters that they take must have a type. So whenever you declare a function, right, you must tell the function the type of the parameter that it takes. So in this case, maybe it takes a parameter string, let's say everybody, right? So I'll do everybody string like this. So that function, our function will know that, oh, maybe it takes a string parameter. But then what actually does it return? It will also return a string. So we must, the keyword is that we must tell our function what it actually returns over here too. So before we open our curly braces like this, we must also say that, oh, this greet function return a string like this. When we do this, now we can come and return whatever, or we can come and do whatever our function is supposed to do. So over here, we want to just say good evening, everybody. So we can just return, oh, return good evening, and then maybe everybody like this. So this is a string. Now let's come and call our greet function. So we can just call our function by using the function name like this. So greet, and we'll give it a string because you know that it takes a string. You know, let's make use of variables. So we can say, oh, maybe everybody, or let's just say maybe group will be equal to maybe everybody like this, and we'll say greet, right? So when we call this greet group function, it will essentially pass everybody to this greet function and then return good evening plus everybody because we passed everybody to it. You know, let's run this, right? When we run this, we'll see that, okay. So another nifty thing about Go is that you can't essentially import something that you don't use. You can't declare variables that you don't use. So you can see that FMT on line 3 has been underlined. And when we hover on it, it will say that we imported it, but we didn't use it. You know, other languages don't really have this. They will just, you know, gray it out or something. But Go is telling us that we've imported it, so we have to use it. So yeah, when we run this, we see that nothing happens, right? Nothing happens because this function is returning. So it just returns. I actually have to print it to standard output. So we can maybe wrap this in a print, right? So we can do fmt dot print, and then we'll just give a function call to it like this. We'll do this so that will just everybody will be happy. So it says good evening, everybody. So this is how you write a basic function in Go. There are also, you know, functions that don't return anything. Maybe if you want to write a function that just does something, maybe it just prints hello world or it just prints good evening everybody, you can get rid of the string over here and you won't use the return because in this case the function won't return anything. So we can just we'll just print and then good evening everybody like this. So in this case we won't have to put it in a print again. But yeah, that's pretty much it. There are a lot of nuances around how functions are, but I think on a very basic level, this is how functions are supposed to be. And also, a function can return multiple things, right? So if we come back to our presentation over here, you see that functions can return multiple values. And the one thing that you'll be seeing a lot in Go programs are that whenever you call a function, they will return a value that is maybe the result of whatever computation the function did and an error, if any. And so it's something that we might also want to take note of when we are also defining our function. So we can see that, oh, this divide function over here takes two parameters a and b, which are floats, but then it returns a float and also an error. It's an error object. And let's actually get into VS Code and let's try to do something similar, right? So let's define a function called divide, right? So we'll do func keyword and then write the name of our function, which is divide, and we'll give it some parameters a and b and the type. So another thing is that if you know that all the parameters you are giving to your function are going to be of the same type, you don't have to do a maybe float 64, b float 64, c float. It makes everything very long, right? Nobody really wants to read long code because who wants to read long code, you know? So yeah, Go, you can just add the type at the very end so that the compiler will know that, oh, a is of float 64, b is also of float 64, and everybody is happy, you know. And yeah, so in this case, we are trying to demo functions that return multiple things. So maybe if we divide a and b, we'll get a float, right? So if your function will return two things, you also need to initialize another bracket over here. And what is the first thing our function is going to return? It's going to return a float, because if we divide a and b, we are going to get a float. Then if an error occurs, we would want to maybe print some error to the user that, oh, maybe an error occurred, because why are you trying to divide 10 by 0? You all know how you can't really divide a number by 0, right? So if maybe the user tries to call our function maybe 10 with 10 and 0, we'll just tell him that, oh, why are you trying to divide by 0? And then we'll bounce him. So yes, we'll add our curly braces, and then so first we'll check whoever is calling a function. You know, denominators cannot be 0 if we are doing division. So we'll do, oh, is b 0? If b is 0, we'll turn an error. And so another thing we'll get into later, conditions, but let me just use them here so that we'll get into it later. So we can say, oh, if b is 0, what will we do? We'll return, so this one will return two things, right? Obviously b is 0, so we have to return an error, but we can't do the division. So let's give the user some 0b so that they'll be happy. You know, they won't say that we didn't give them a number. So let's give it return 0 and then say, oh, maybe format dot error f. So error f is like a function that we can use to print error objects out. So it's just like printf, but for it's just like print line or printf, but for errors essentially. So we can say, oh, maybe cannot divide by 0. And after we are done, we know that, oh, b is not a 0, so we can just divide it for them. And then we'll do return a over b and then nil. So nil essentially says that, oh, there was no error, right? So in this case, we have to find something to return as this error objects, but no error occurred, so we'll just do a nil. So nil is also, you can look at it as a type, right? So this is what our divide function will do. And then we'll come and call our divide function. So like when we are calling a function, like we all know, we'll type the function name, which is divide, and then maybe we'll give it two values, maybe 10 and then 0. Now, another thing that we can do to functions in Go is that we can assign the result of function calls into variables. And so this divide like this, now that we know that it returns a float and an error, we can actually define variables that will hold the floats and errors respectively. So we can do something like, oh, maybe results and then error is equal to this divide. So this divide will return two things. The res will hold the first one, which is the float. The error will hold the second one, which is the error. Now we can check. So we know that there's a possibility of an error over here. So we have to check, oh, if error is there, we'll tell the user that, why are you trying to divide by 0? If not, we just give them the result that they want. And so we'll make use of another keyword over here called the if. So this is something that it's almost like a convention in Go at this point. You know how in other languages they use try catches and all. Go doesn't really, use try catches because they are very long. Nobody wants that. So instead of doing the whole try catch and patching up your code, you can just check if the error is not null. So if an error actually exists, we'll say, oh, maybe and we'll print the error to the user, right? Like this. If not, we'll just print the results. So we'll say, oh, we'll print this, and then we'll print the results like this. Let's run it and see what happens. So over here, right, 10 and 0. So we'll come to this divide function and it will check if b is 0. If b is 0, it will return this. So let's run this. So you see that we get an error, which is error cannot divide by 0 and 0. That's what we give it. Now if we do maybe 10 and 5, obviously it's possible. So we'll get 2 because 10 divided by 5 is 2. So that's like another thing that we might want to keep track of when we are declaring functions. It's actually something that you'll be seeing a lot in Go, and by a lot I mean a lot. Almost all functions that you might call in Go programs, whether APIs or whatever, will return some kind of error of some sort. So you might be using this thing a lot to change the execution flow of your program. So let's continue. And the next thing will be coming to our flow control loops, if, switch, and defer, right? So when you're writing programs, right, there are instances where you want to do something multiple times, or maybe you have some collection of values over there that you want to do something to them, and you want to do something to each individual value, right? Do it with something called a loop. And again, if you are familiar with other languages, you know that there are while loops, there are for loops, there are do while loops, etc. But in Go, the for loop is the only looping type that we have in this language. So everything is kept as simple as possible. And so depending on what you are doing, right, you can tweak the for loop to fit whatever use case that you have. And so you can use it for fixed iterations, for conditional loops, or for infinite processes or infinite loops, essentially. So let's look at how we can define for loops in Go. Let's head over to VS Code again. I'm going to comment this out. Let's remove this. Right. Let's say maybe we want to count from 1 to 10. Right. So we'll use the for keyword. So there's a keyword called for that tells or that says that, oh, we are trying to declare a for loop, right? So we'll do this. Let's get rid of the FMT maybe when we need it to come. When we do this, right, now, since we are counting from 1 to 10, right, for loops actually take three things. The first thing is called initialization. So your loop has to start from somewhere and end at somewhere. So the first place it starts is called our initialization. So in this case, maybe we want to count from 1. So we can do, a lot of the times you see people use I. So we'll do, oh, maybe for I, so I is a variable. So we can just use the infer declaration to do if for I equals 1, and we'll do a semicolon like this. Then when do we want to stop our loop, right? Since we are counting from 1 to 10, it means that our loop will start at 1 and end at 10. So we'll stop our loop when I becomes 10. So we'll do, oh, if I is less than 11, because in this case, we want I to stop immediately after it becomes greater than 10, right? So maybe I is less than 11. So I will start from 1, 2, 3, 4, 5, 6, 7 to 10. And as soon as it becomes 11, it stops, right? So this will be the initialization, and this is called a condition. So a condition essentially tells your for loop how long it should run. So we have the first part and the second part clear, and our third part will be a post statement. So a post statement basically means that so after your loop has run, you know, you want to do something so that at least maybe you would gradually steer the loop toward a breaking, or you gradually steer the loop toward an end. So in this case, you want to increment I so that maybe since I is 1, I is less than 11, we would increment I so that I becomes 2, and then I would eventually come and it will reach what's it called, our condition over here, and then the loop will break, right? So we'll do this and then we'll add some curly braces, and maybe we want to print, so we'll call FMT again like we've been doing, and we'll print maybe count this, and we'll print I like this. Cool. What are they saying? We'll not import. Let me get rid of you. Okay, cool. So let me do this. Okay, cool. Now we can run. So when you run this, right, we see that it counts 1 all the way to 10. So what actually happened here is that I was first 1. Now loop will check. Is I less than 11? Yes, I is less than 11. Then it will come and run this. It will print I. So I will be 1. And after it has printed 1, it will increment I. So this plus plus here essentially means that we should add 1 value to I. So since I is an integer, when we increment it, it will add an extra 1 to it. So now I becomes 2. So I will become 2 again, and it will check. Is I less than 11? Of course, 2 is less than 11. And it will print. Count is 2. And it will increment I. I becomes 3 all the way to 10. And then, when it gets to 11, obviously 11 is not less than 11. It's equal to 11. So this condition will break, and then our loop also stops. So this is a traditional, counting loop in Go. And if maybe you're coming from a different programming background where they use while loops and all, and you want to do something similar in Go, right? You know how in other languages you do while this, and then you do this. You can just tweak the for loop to actually do that. So maybe we want to also count to 10, just like that, right? So just like we did with the for loop, let's do like with a while style loop. So we can do with the for keyword now. So type for, and then obviously we would use I. So it means that, so the nifty thing is that over here on line 6, we got to actually declare I in line when we're doing our for loop. But since this is a while style loop, right, and then we also want to maybe count from 1 to 11, we'll do something like I is less than 11, which means that we need I, because we can't come and do I equals to this and then then it means it's the same thing over here that we are doing, right? So we need I at the top so that we can use it in our while style loop. So we'll do maybe I equals 1, and then we'll check for I is less than 11, and then we'll print maybe while count, and we will add our I. So after we do this, right, we will also need a post statement because mind you, I is 1, and we'll check, oh, is I less than 11? Yes, I is less than 11, and it will print. But the funny thing is that if we run this, it will keep printing while count 1, while count 1. And this is because we don't have a post statement. So what our post statement also does for us is that it protects us now. So it means that our loop won't keep running forever. It won't waste memory and whatnot. So we also need a post statement over here. So like we did above that we were incrementing I, we'll also come and increment I so that we'll gradually increment I to the point where I becomes 11 and our loop will stop. So when we run this again, we see that that's the same thing, right? So it prints 1 all the way to 10. And so this is like a while style loop. How do you do it in Go? Maybe if maybe you want, for some reason, you want your loop to run forever. Maybe I don't know what you are doing that you want the loop to run forever. Maybe you have some background job somewhere, or you have a web server somewhere that you want to keep it in a loop. You can just do the for keyword and then just initialize it with curly braces, and maybe we can print maybe run forever like this. So when we do this and run, you see that our loop also runs forever until we manually terminate it. So what we can do here is that there's also something called a break where we can just use to break our infinite loops. So we'll come to this break later, but the point is that this loop is supposed to run forever. But then when it prints run forever and it gets to break, our loop will break. So this will print only once. Right? So we see it prints only once because it gets to break and then our loop just stops. Another thing that I also want to talk about is range or range-based loop. So you see how we talked about composite types in Go. We talked about arrays, slices, etc. Right? Maybe sometimes we want to loop over array, or sometimes we want to loop over a slice. Let's say we have a group of numbers somewhere that we want to loop over. Right? So let's say a slice. So we'll do our int, and then let's say 10, 20, 30, 40, 50, etc. Now, maybe when we look through this, we want to do something with the index, or we want to do something with the position of the value of 10. And we also want to do something with 10 itself. We can use a range. Now, what range actually does is that it gives us a way to loop over collections, like we've said, but then it gives you both the index and the value at each stop in our loop, so that our loop can be very concise. So 10 is at the index is 0. You know how when you're counting something in programs, it always starts from 0. So it's the same in Go. So 10 would be at position 0, 20 would be at position 1, 30 would be at position 2, etc. So if maybe you want to do something with all of these and you also want to do something with the indexes or the indices, you can use the range. So when we are looping through our nums, we'll do for, then let's say range nums, open our curly braces. But over here, we want to do something with the key or the index and then the value. Right? So we would have to initialize some variables in our loop like we did over here at the top. So like we did for I equals 1, we can also do for index equals range of nums, but it's just like this, but it's not like this because the range gives us two things. It gives us the index and the value. So n. For I and n in range of nums, we can print maybe I and then n like this. So when you run this, so that it gives us the ability for us to tap into the index. So 0, 10 is at index 0, 20 is at index 1, 30 is at index 2, etc. etc. So there are some situations where maybe you want to do something with it. I don't know, it depends on you and the code that you're writing, but just in case you are looking over a collection or maybe a composite data type in Go that you would need the indexes and the values, you can use the range to do that. Maybe sometimes if you don't even need the value, maybe you only need the index, You can ignore the value with an underscore because again, in Go, you can't necessarily say that, oh, I'm initializing the variable to hold the values, but I won't use it. The compiler will hold your neck. That, why are you doing that? So you can ignore it with this, and then maybe you can just print only the I like this. Or maybe if you only need the values, you can also ignore the index with this and come and do this, and also you come and print the values. So then wherever you see the underscore, it means that, oh, this underscore essentially tells us that this place might hold a potential variable, only that we don't need this variable at this point in time, and so we are ignoring it. So the Go compiler looks at our underscore and says that, okay, whoever is writing our code doesn't need the index, right? So they've ignored it with an underscore, and then our code doesn't break and everything goes ahead. So that is it for loops in Go. Another thing we might also want to keep track of
Yeah.
are
Sorry for interrupting. I
okay,
don't know, but I'm so soaked with the presentation. Thank you. We have 5 minutes more, so
okay.
yeah. Thank you very much.
Let's talk about if statements and switch statements, right? I think that'll be the last thing we'll talk about. So there are sometimes when you're writing a program where you might want to change the execution flow of your program depending on what you want to do. So remember how we checked if an error was there and then we did something or we printed an error to the user, right? We can use if statements for that. So assuming maybe today is Saturday, so we can do today is Saturday, and I want to check what day today is. So we can use an if for that. So we can do if today is, so whenever you see this double equal to, right, it's basically the Go version of is in English, right? So if today is maybe Saturday, we'll just print maybe today is Saturday. Assuming maybe we're checking all 7 days of the week, we'll come and do if today is Saturday, we'll do this. Else if there's something called an else if, which gives us the ability to do multiple conditionals at a time. So else if today is maybe Tuesday, we'll print today is Tuesday, etc., etc., etc. And finally we'll get an else, right? So if today is not Saturday and today is not Tuesday, maybe today is any other day, we have 5 days left, right? We can print maybe today is any other day. But you can see how complicated this thing can become. Assuming we're not checking today, but we're checking years. You know how there are thousands of years, our code becomes very cluttered. We'll do if else, if else, if else. It's a lot, right? So another thing that Go gives us is, so it's even telling us that we can use a tagged switch on today. So instead of us always using if and else if statements to clutter our code, right? We can use switch statements. And switch statements are essentially they are like if conditions, or they are like if statements, but they are more concise, right? So you don't necessarily have to be typing if and else if on each line. You can just use a switch. So let's say we're doing or we're checking what day today was. We can just use a switch keyword to check. Oh, so when you type a switch, right? You need what's the code? The variable that you're checking or the condition that you're checking, right? So maybe switch today and then open it with curly braces. Then inside the switch, it holds something called cases. So cases, if we're comparing it to if statement, would be maybe something like this. Today equals Tuesday, but in switch, we call them cases. Assume maybe we want to check if maybe today is Sunday. So write case Sunday, then we'll do a colon, and then we'll type maybe we'll print Sunday. Then maybe we'll have another case where today is perhaps Tuesday, and then we'll do Tuesday, right? But assuming today is not Sunday and today is not Tuesday, obviously it's not because today is Saturday. We can tell our switch statement that, oh, by default, if none of these cases are met, we want to actually do something else. So it will be a default case or a default behavior that we want our switch statement to have. So we can do a default and then print, oh, maybe any other day. When we run our program like this, it prints any other day because today as a variable is Saturday. When we switch on today, it will check, is today Sunday? No. So this won't execute. And it will come and check, is today Tuesday? No. So this won't execute. So by default, if these two cases are not executed, it means that today is any other day. And it prints any other day. The last thing I want us to talk about would be defer statements. Defer statements are used in Go for resource management, right? So when you defer something, you essentially say that, oh, don't run right now. Run when, the surrounding function is done. So assuming, let's say we open a file, right? Sometimes when you're writing Go programs, you might want to open a file to do something with it, or you might want to just maybe some database transaction somewhere or something, anything. But the idea is that you don't necessarily want that particular statement to execute instantly. You want it to execute after our main function here has done executing. So we defer the execution of our statement. So we use the defer keyword. So maybe defer. So assuming, let's say we have some code that prints, assuming we are reading a file. So let's define a function that reads a file, which we take maybe a file name, right? And then we'll print. Obviously, this is all simulated for demonstration purposes, but I will print maybe reading file. Then let's have like 3 more lines of this. Okay. So this has to be switched. Okay. Then after our file has been read, right? We'll come and say that, oh, maybe we want to close our file. So we'll do defer maybe, and then we'll say, oh, close file, right? So when we do this, what we do is that let me put this here. Let me put this here so that we understand. So when we do this, right, it means that when we call our read file function with a hypothetical file name and then we read our file, it will print reading file on line 6, it will print reading file on line 7, then it will come to line 8. Oh, we want to close the file. But then maybe on line 9, we are still reading the file, we are not done. But we know that at the end of this read file, we want to close the stream of input that we've opened. Maybe we want to cause some memory leak or something. So we'll defer the closing of the file. So it will mean that at the end of line 9 or at the end of this function read files execution, only then will this print line be executed. So maybe to test, we'll do this and then we'll say, oh, so like this. And so you see it prints reading file, reading file, reading file before it prints close file. It means that this one over here was the last thing that was printed. So it printed the first one, the second one, the third one, before it came to print this. So it's also a very nifty thing that Go allows us to do. If you're coming from a different programming language background like Java and C Sharp, the way you do this is a lot. You have to do some skirmishes B, but in Go, just use the defer keyword and you'll be happy with your life and you'll be happy with your code. So that's also it about defer statements. Like we said, they are executed in last in first out order after the surrounding function returns. And by last in first out, it essentially means that the last thing in our function will be the first thing that will print. Right? So assuming maybe we had a deferred chain of print line statements, maybe third, then we had another one second, and we had another one first. So let me name this second, let me name this first, right? What will actually happen is that since the first statements are executed in last in first out order, it means that when we print this, the first will be the first thing to be printed, the second will be the second thing, and the last one, which is a third. So if I run this, you see that first, second, and third exactly. So it's like the reverse of this because it's last in first out order. So it's also something you might want to keep an eye on when you are using the first statements. So that would be it. And yes, so this brings me to the end of my presentation. So we've covered packages and imports at the very beginning. We also covered what variables are. We looked at constant variables. We looked at some types, which are the basic and the composite types. We also looked at functions, right? We know that functions take parameters and they return something. And then functions can also return multiple things at a time. We also looked at control flow, which are essentially our if statements, our else statements, or our else conditions. And we also looked a little at switch statements. And the last thing we looked at was defer, which again was the last thing that I literally just said minutes ago. So yes, this brings me to the end of my presentation. And at this point, maybe if you have some questions, clarifications, or some thoughts, or maybe you just feel like talking, yeah, the floor is yours. You can raise your hand and share your opinions. But This will bring me to the end of my presentation. So thank you everybody for attending.